All right, so we're back. This will be the third video for week one's notes. Hopefully you have those notes from on a PDF that I emailed out. Okay, let's get going here. So I'm going to switch over. Okay, so we are going to be looking at a sample space when two dice are rolled. So I said, look at the six-face die, which is given below. This six-face die has the numbers 1, 2, 3, 4, 5, and 6 on its faces, they call it. All right, let me see if I can dial this in a little better. So we know our sample space is 1, 2, 3, 4, 5, 6. So the total number of all possible outcomes when you roll a die we know is 6. Okay, so we've been kind of working with that, but now we are going to kind of upgrade and we are going to understand the sample space of rolling two die. Okay, so here's die number 1 and here's the other die here. Okay, so let us understand the sample space of rolling two die. For example, what does 4, 3 stand for? Okay, so if we find 4, 3 right here, that stands for getting 4 on the first die. So this is die number 1. And getting a 3 on the second die, number 2. Or 1, 1 would be, a 1 on the first die and a 1 on the second die. Or let's just look at 1, 6. So 1, 6 is right here. Means you rolled a 1 on your first die and a 6 on that second die. So we'll be referencing this chart to help us answer some future problems coming up here in a second. The other thing to think about too is you also can add up the sum. So let's say you rolled a 1 and a 6. So if you rolled a 1 on die 1 and a 6 on die 2, you would add that together and that would be a total of 7. Same thing here. Let's say you rolled a 4 on die 1 and a 4 on die 2. 4 plus 4 would give you 8. Okay, so keep it moving. Compute the probability. Oh, the probability that the sum is greater than 7 when you toss two dice. Round your answer to 2 decimal places. Okay, so for this, I'm going to grab a highlighter. So what I want to do is highlight all of the possibilities where the sum is greater than 7. And here's a cool little trick. So if you start to think about things on the diagonal here, 1 and 1 is 2. So that's not going to be greater than a 7. And then 2 plus 1 is 3, 1 plus 2 is 3, so that's not going to work. So I'm kind of thinking about it's not this, it's not going to be these. Okay, look at this next diagonal. 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4. So it's not going to be these. 4 and 1, 3 and 2, 2 and 3, 1 and 4, all going to add to 5. So still none of these have a sum that's greater than 7. And so see how it kind of works on the diagonal? This is 6, 6, 6, 6, and 6. Still not greater than 7. All right, here's 7, 7, 7, 7, 7, 7. Now I cross those off because it specifically says it has to be greater than or more than 7. So it looks like this if you think about it as an inequality. It's not greater than or equal to, it's just greater than 7. So that means that 6 and 2 come into play. Because that makes 8, 8, 8, 8, 8. This, of course, is going to be 9s. This is 10s. This is 11s, and this is 12. Okay, so hopefully that helps visually. So the probability, remember, we are looking for the probability that the sum is greater than 7. Okay, well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 possibilities of that happening. Out of all of these is 36. So if you think about it, like this is 6 here, right? And this is 6 here. And 6 times 6 is going to give us that 36. Now, they said round your answer to 2 decimal places. So that means Alex is not going to be happy with this fraction. So we're going to do 15 divided by 36. So it's going to be 0.41666, and it keeps repeating. So 2 decimal places, we're out here at the hundredths place. So you're going to mark your territory. So 2 decimal places is this guy right here. Put up a wall Your 1 here is going to look at that right there. That 6 is going to tell that 1 to round to a 2. So we have a 42% chance, or a 0.42 chance of rolling 2 die, and the sum is greater than 7. Okay, so I have one for you to try. Compute the probability that the sum is not divisible by 2, and it can't be divisible by 6. Again, round your answer to 2 decimal places. Okay, pause the video, and I want you to go through and think about which one of these you could, that are going to be meeting these standards, not divisible by 2, not divisible by 6. And so we'll meet back in a minute. Okay, so if you take a look at this first diagonal here, we got 1 plus 1 is going to be 2. Well, we're not allowed to be divisible by 2, so that's going to go out of here. Then if the next little diagonal is 2 and 1 and 1 and 2, that's going to make a 3. So those are not divisible by 2, and of course not divisible by 6. So we're going to grab those. You're going to start to see a pattern here. 3 plus 1 is 4, and 4 and 4. Well, that's divisible by 2. So we're just going to get rid of those. Keep working on your diagonal. 4 and 1 is 5, 5, 5, 5. Well, 5 is not divisible by 2 or 6. Okay. Okay, let's keep going. 5 and 1 is 6, 6, 6, 6. Okay, well, 6, we cannot have that. 6 is divisible by itself and divisible by 2. So we need to knock these out. Okay, these are 7s. All right, so 7 is not divisible by 2 and it's not divisible by 6. So we're going to accept those. Okay, we want those because that makes that not divisible by 2 and not divisible by 6 standards. So this is going to be 6, 7, 8. Well, 8 we know is divisible by 2. So that's got to go. 6 and 3 is 9. So all of these 9s, we're going to accept these. Because 9 is not divisible by 2 or 6. So do you see a pattern happening? I'm sure you do. So 10, we got to get rid of 10s because 10 can be cut in half by 2. But we'll take these 11s. That's not divisible by 6 or 2. And then 6 and 6 is 12. We definitely got to get rid of that because it's divisible by 6 and 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 out of 36 that will qualify for a probability that the sum when you roll 2 dice is not divisible by 2. So you're going to put this in your calculator, 18 divided by 36, and I'm getting a 0.5. So they want us to round to 2 decimal places, so I'm going to put a 0 there. So the probability is 0.5. So hopefully this is going to help you with these types of problems on ALEKS math. Okay, probability involving 1 die or choosing from n distinct objects. All right, let's see what they have for us. A bag contains 6 tiles labeled B, C, D, E, F, and G. 1 tile will be randomly picked. What's the probability of picking a letter that is not a vowel? Okay, so remember, vowels are like A, E, I, O, U. So think about your vowels. We don't want to pick one. So pause the video and then come back and see if you get the same thing I'm going to get. Hopefully, see if we match. Okay, so the only vowels in this lineup are E. Okay, so we don't want to select that. So the probability of picking a letter that is not a vowel is going to be all the others. 1, 2, 3, 4, 5 out of 6. So hopefully you got that. A bag containing 8 cards with these little labels on them. We have 1 card that's going to be randomly chosen. What's the probability of choosing a letter from Q to W? Okay, so we've kind of seen something like this a little earlier in one of our earlier problems. So the probability of picking a card and we choose a letter from Q all the way to W, that would exclude P. So out of the total, we have 1, 2, 3, 4, 5, 6, 7, 8. And these would be 7 out of 8. So that's the probability of choosing a letter from this selection of Q to W. Okay, we're going to keep it moving here. We have an aquarium. So this is probability of choosing from objects that are not distinct. Okay, let's see what they're talking about. In an aquarium, there's 4 large fish and and 16 small fish. Half of the fish are blue. One fish is selected at random. Find the probability that it's a small blue fish. Okay, so I'm a visual learner. I think I've mentioned that in these videos. So I need to write this out. So I have 4 large fish. So I'm going to write them out here with representation. I have 16 small fish. So bear with me. I'm going to write out all my small fish. And for those of you visual learners, hopefully this is going to help you. And then we have the other thing that it says is that half of the small fish are blue. So I'm going to circle half of my small fish because they're blue. Okay. One fish is selected at random. Find the probability that it's a small blue fish. Well, we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 total fishies. And the chance that we're going to select one fish that is a small blue fish are these guys right here. So these 8. So that's small blue fish. Okay, so that wasn't too horrible. As long as we can write this out, for me, I need to see that. Now, 8/20, it's probably something where we want to try to, if we can, reduce. So 8 divided by 4 we know is 2. 20 divided by, cut up into 4 chunks would be 5. Okay. So they might want 8/20, but if Alex gives you like a warning, they maybe want you to reduce it. Okay, so let's go a little further. Probability of an event and its complement. Okay. So what does complement mean? For any event E, if E, and you're going to see like a little ticker mark, okay? That means the complement. So for any event E, if E with a ticker mark is the event, E does not occur, then the probability of the complement of E is equal to 1 minus the probability of E. Okay, so that's kind of a lot to kind of digest here. So sometimes we call this prime. Sometimes we call it the complement. So let's see if maybe working through a problem will help you with kind of this definition here. Okay, 8 balls numbered 1 to 8 are placed in the bag. Some are gray and some are white. The ball number 2 is gray. Okay, so this one is gray, they're telling us. The balls number 1, 3, 4, 5, 6, 7, 8 are white. All right, a ball is selected at random. Let X be the event that the selected ball is white. And then let probability of X be the probability of X. Let not X be the event that the selected ball is not white. And let P, probability not of X, be the probability of not X. Okay, so that's an awful lot to think about here. Let's see if we can digest this. Okay, so the first thing they want us to find out is what's the probability of X? Well, the probability of X is that you select a ball that is white. Well, we know that all of these balls except for that one are white. So if you were going to find the probability that you would stick your hand in here and find a white marble or ball, it would be 7, all 7 out of the total of 8. Now the complement of probability of X or not X is what's the probability that the selected ball is not, see it says not white. Well, that's only 1 out of 8. So the whole goal to complements here is if you were to add these two together, so you find the probability that it's white and the complement, or the probability that it's not white, if you were to add them together, you would get 1 or 100%. Okay, so that's where this sort of kind of comes into play, this little formula here. So it says the probability that it's not white is going to be equal to 1 minus the probability that it's white. So the probability that it's not white is equal to 1 minus the probability that it is white. Okay, so we know the probability of not white is 1/8. So 1/8 has to be equal to 1 minus the probability that the ball is white. So 1 minus 7/8. Well, if you haven't done fractions in a while, we need to kind of refresh ourselves with this. So is 1/8 really equal to 1 minus 7/8? Well, remember with fraction lands, you're not allowed to add or subtract fractions unless you have the same denominator. So if I were to just off to the side here, write this 1 minus 7/8, what you could do is put this 1 over a 1. You could put any number over a 1, it doesn't change it. Now the common denominator here is we need to make them into 8s. So you can multiply this by 8 and this by 8. And that's going to make that 8 over 8 minus 7 over 8. Now we have common denominators. And keep in mind, 8 over 8 is just still 1. 8 divided by 8 is still 1. So all we did is take 1, which could be, let's just call that Superman, and then multiply it by 8 over 8, and now it's Clark Kent. But it's the same person, just in a different outfit. Now, once you have your common denominators, you just subtract the tops and keep the common. So 8 minus 7 is 1/8, which is equal to 1/8 here, the probability that it's not white. So I know complement can be a little confusing. Hopefully we're going to have some more practice with this as we head through this week's homework. Okay, we're coming into our last question here. Experimental and theoretical probability. Okay, Shamika rolls a number cube 1,000 times and gets the following results. And here's the outcomes. So 1, 2, 3, 4, 5, and 6 on the cube. So for example, she rolled the number 1 169 times, the number 2, she rolled it 136 times, and so forth. From Shamika's results, compute the experimental probability of rolling a 5 or a 6. Okay, so we know that the probability of rolling a 5 or a 6 is going to be the number of times we rolled a 5 or a 6 over total number of rolls. Okay, well, we know the total number of rolls was Shamika rolled it 1,000 times. And then she rolled a 5 156 times and a 6 173 times. So if we add those together, let's see what our numerator would be. So sorry about the glare here. Oopsie, calculator is dead. 156 plus 173. Okay, we get 329 over 1,000. So if you take 329 and divide it by 1,000, let's also give it a decimal representation, or 0.329 is our theoretical probability. So almost 33%. If we were to put this into percent or think about it percents, that if Shamika rolled a number cube 1,000 times, we have a 33% almost that she would roll a 5 or a 6. Okay, assuming that the cube is fair, compute the theoretical. What in theory should Shamika really get when rolling a number cube 1,000 times for rolling 5 or 6? Okay, so remember, it's the number of ways of rolling a 5 or 6 over number of possible outcomes. Okay, so think about this die, right? So you got your little cube, right? You got your die, you go and roll it. And the number of ways of rolling a 5 or 6 or on a 6-sided die is just going to be 2 out of 6, which is 1/3. Okay, which is, if we put this in our calculator, 0.333, which look how close the theoretical probability is to what Shamika actually got. So Shamika ran an experiment and got like roughly 32, 33 or 0.329 or 33%, we'll say. Let's just change that to a percent just to make that kind of, I like percents better than decimals. So 32.9% versus, let's change this one to 33.3%. So this was an experiment that Shamika ran, and this is what we know should happen in theory. And look how close they were. So they were off by just a little bit. They're both essentially 33%. And see, Shamika rolled that number cube 1,000 times. So what happened here is something very important that I kind of alluded to in the very beginning of these videos, is that our experimental probability is going to be close to the theoretical probability as the number of, sometimes they use the word trials or experiments increases. So something to keep in mind is that the more and more trials that Shamika runs, or more and more experiments that Shamika runs with this die, the closer and closer her experimental probability is going to get to her theoretical probability. Okay, hope that's helpful to you, to help you get through your first week. If you are in my online live class and you're watching this video, I'll see you next week on January 16th at 7 p.m. Of course, you can email me anytime. And if you are in my online class, you're welcome to email me. All right, enjoy. Hope this helped.